Welcome to The Explainer. Today, we're taking a fascinating look at the hidden battle raging right inside your walls. It's the intense structural conflict between extreme local weather and your home comfort systems. If you've ever found yourself wondering why your AC just totally taps out on the hottest day of the year, or why your winter heating bills suddenly skyrocket, well, you're in exactly the right place. We're going to dig into some fantastic local climate data and professional HVAC insights from Middle Tennessee to show you exactly how this hidden mechanical world operates.
Here's our roadmap for this explainer. First, we'll look at the local climate challenge, then common system breakdowns, professional standards and solutions, the age-old repair versus replace dilemma, and finally, the three-step service process.
Okay, let's dive right in. Section 1, the local climate challenge.
Let's set the stage by looking at the environmental baseline for a place like Vergne, right in Middle Tennessee. Just look at the brutal temperature swings we are asking our home machinery to handle. In the summer, you've got temperatures regularly pushing past 90 degrees, and that's coupled with an absolutely oppressive 70 to 90% humidity. Then, fast forward to the winter months, and we drop way down to freezing nights between 20 and 30 degrees. This isn't some gentle, moderate environment. This is a climate that puts non-stop, year-round stress on heating and cooling equipment. Seriously, a window unit that might survive a mild spring in another state, it would get absolutely crushed by a Tennessee August.
And it's not just the temperature either. Hyperlocal factors are literally breaking down machinery. For example, shifting red clay soil moves with moisture changes, which physically stresses and separates the hidden ductwork in your crawlspace. It's like an earthquake in slow motion. Plus, if you live near Percy Priest Lake, you are dealing with a massive localized moisture load that seriously strains your system's dehumidification capacity. And hey, if you're near a busy route like Veterans Parkway, fine road dust is clogging your air filters way faster than the average rate. These factors don't just happen outside, they actively attack your infrastructure.
So what actually happens when that infrastructure gives way? Let's move to Section 2, common system breakdowns.
One of the absolute most destructive mechanical failures a system can suffer is what's called short cycling. Basically, this is when your system turns on and off repeatedly without ever actually heating or cooling your home properly. It's an endless, damaging loop. And the crazy part? This doesn't just happen randomly. Our sources point out that short cycling is often caused by specific underlying failures. We're talking about things like a dirty flame sensor misreading the room, a failed limit switch, or even a system that's just improperly sized, too big for the home so it heats the space way too fast and shuts off prematurely. This loop literally shreds your components over time.
So how do you know if your system is caught in one of these destructive loops? Well, the warning signs are undeniable. You might notice uneven room temperatures, where, one bedroom is an absolute icebox and the living room feels like a tropical sauna. You might hear aggressive grinding, squealing, or banging noises. That usually means blower motor bearings are wearing out or compressors are on the brink of failure. And honestly, the most painful symptom? Your energy bill's randomly climbing by 15 to 20% without any explanation. That right there is your physical discomfort directly translating into a mechanical breakdown and financial loss.
Which brings us to a really crucial question. Why does your AC struggle so much with summer humidity in the first place? Think about the incredible mechanical effort required here. In a 70 to 90% humidity environment, your air conditioner isn't just lowering the air temperature. No, it's simultaneously acting as a massive water extraction machine. It has to pull incredible volumes of water vapor right out of your living space. If your coils are dirty or your refrigerant is low, that moisture extraction drops drastically, and your poor system, it just runs constantly to try and keep up.
When things break down this severely, guesswork just doesn't cut it. Section 3, professional standards and solutions.
What is truly staggering here is a single number, 20 to 30%. That is the amount of heated or cooled air that is entirely wasted through leaky, improperly sealed ductwork in a typical home. Imagine that, paying for 100% of your energy bill but only actually feeling 70% of it? No way! This is exactly why professionals don't use standard duct tape, which ironically fails pretty quickly on actual ducts. They use proper mastic or approved sealing tapes. It's a precise, highly technical standard required to actually stop that invisible financial drain.
And speaking of technical standards, federal law actually dictates who can handle the chemicals inside your AC. Refrigerant handling requires EPA certification under Section 608 regulations. This isn't just a friendly suggestion, it's literally the law. Modern systems, especially those using R410A refrigerants, require incredibly precise measurements. Adding refrigerant isn't just, topping off a gas tank. It requires exact calculations based on line length,
outdoor temperatures, and specific subcooling and superheat measurements. If you overcharge it, you destroy the compressor. Undercharge it, and the coils freeze solid. It's a delicate balance.
To really protect your home, professionals have to rely on hard data. They don't just guess what size unit you need. Instead, they use what's called a manual J-load calculation. This accounts for your home's square footage, insulation, windows, and all that local climate data we talked about earlier. For a typical 1,500 square foot home, that usually means a 2.5 to 3-ton unit. They also run really rigorous safety checks, like testing exact gas pressures at the valve and inspecting heat exchangers for microscopic cracks. Because trust me, you do not want deadly carbon monoxide leaking into your living space. It is a highly scientific diagnostic process.
But what happens when all that diagnostic data brings you bad news? Section 4, Repairing versus Replacing Systems.
Chronologically speaking, here is the harsh reality of how long these systems actually survive under local climate stress. Heat pumps generally last about 12 to 14 years. Why? Because they work year-round, doing both the heating and the cooling. Air conditioners manage about 12 to 15 years. But notice the furnaces. They can hang on for 15 to 20 years. The difference is pretty simple. Furnaces only operate during the winter months, so they take way less overall annual wear and tear, compared to the systems running non-stop through those brutal 90-degree summers.
So, the million-dollar question is knowing when to pull the plug. The classic dilemma usually comes down to the 50% rule. If your system is under 12 years old and needs a minor fix, like a new capacitor, you definitely repair it. But if your unit is over 12 years old and the repair costs exceed 50% of the system's remaining value, at that point, it's just financially logical to replace the whole shebang. This is especially true if you're running on phased-out R22 refrigerant, which is increasingly expensive and obsolete. Plus, get this, new systems operate 30 to 40% more efficiently than models from just a decade ago. It's a real game changer.
Once you make that decision, how do you avoid total chaos? Section 5, the 3-step service process.
HVAC professionals use a very clear, non-nonsense blueprint to get your home back online. Step 1 is scheduling, getting a real timeline and often getting dispatched immediately for emergencies. Step 2 is diagnosis and repair. This means getting a plain language explanation and upfront pricing before any tools even touch the machinery, and then executing the fix with the right parts. Finally, step 3 is testing and follow-up. This is absolutely crucial to verify the repair actually solved the root issue and to ensure the system is operating strictly within those manufacturer specs we discussed earlier.
Of course, the absolute best repair is the one you never have to make in the first place, right? Fortunately, there are immediate, actionable steps you can take today to protect your investment. First up, replace your air filters every 30 to 60 days. If you've got pets, do it monthly for sure. That airflow resistance absolutely kills efficiency. Second, schedule professional tune-ups in April or May. Do it before the extreme summer heat hits and repair companies get completely overwhelmed with 2 a.m. emergency calls. And third, go outside right now and trim your plants and grass at least 2 feet back from your outdoor unit. It desperately needs that airflow to extract all that summer humidity.
Which leaves us with one final, very important question. Is your home's comfort system truly prepared to survive the next season's extreme climate swing? We've looked at the data, we know the environmental hazards, and we understand the mechanical limits of these machines. They definitely aren't invincible. But with the right professional standards, proper sizing, and active maintenance, they don't have to be a source of constant stress either. Take a close look at your own infrastructure today. Check those filters and make sure you're ready before the weather decides to test your system for you. Thanks for joining me on this explainer, and keep learning.